So I think last time we discussed about a router theory. Yes or no? This one. And we discuss a router identification, fixed series, modular series. Clear? Terminal server we discuss, octa cable. Now, today topic name is again a router. But today we learn which one topic? Packet flow. On switch we are calling data flow. Why we are calling a data flow? Any idea? Why we are calling a data flow? Because data flow on the basis of MAC, and MAC available on frame, and frame available on which layer, dear? Layer 2. And why we are calling a packet? Inside packet we are getting a which one information? IP. And IP information built by which one layer? Network layer. And network layer present on which one layer number? Layer 3. Okay, now how routed packet flow? So we do step by step. For example, if we are getting a router, so this one is my router, and this router 0 by 0, and one more interface 0 by 1. Okay, 0 by 0 connected with your a LAN side switch, and switch connected with some LAN user. This one user 1, this one user 2. Now this side router also connected with a switch, and this switch connected with a server. Right now, this side a separate group or network. Network address is 192.168.1.0 / value 24. PC1, PC2. 1.1 is IP and A is MAC. 1.2 is IP and MAC address is B. 1.1 IP means 192.168.1.1. Now, this side also different group or different network, you can say 192.168.2.0 / value 24. This one is 2.10. MAC address is C. Any doubt, Neil, Gopi?
No.
Now, so basically in this design, we need to discuss packet flow. But before discuss packet flow, can you please verify one thing? Whenever PC1 say, I want to communicate with PC2, so communication is possible or not possible? Whenever
Not possible.
whenever PC generate data, and how to generate data? PC1 opens CMD and write down command ping 1.2. So data will generate data at which one protocol? Ping means ICMP. And which message we are sending? Echo request. And inside data, PC1 add a layer 2, source MAC, destination MAC, and then add one more layer, layer 3, source IP, destination IP. So can you please verify source IP is 1.1, destination is 1.2, source MAC is A, destination is B. Because our process will follow and ARP will be processed because both are sitting into same network. So can you please verify source IP and destination IP, same network member or different network member? Source IP 1.1 or destination 1.2, same group IP, na? This one.
Yes.
So if you communicate in same group, so communication is possible. But if I am saying same diagram, but now PC1 say, brother, I'm trying to communicate from this server. So PC1 opens CMD and write down ping 2.10. That means data will generate. Data add ICMP and echo request layer 2, source MAC, destination MAC, layer 3, source IP, destination IP. So PC1 says source MAC is A, source IP 1.1, destination is 2.10. So right now for PC1, source is known, destination is known. Both are same group member or different group member? First verify. PC1 and server 1, the server,
Different
both are
group.
same? No. It's
No.
a different group. If device trying to communicate in different group, or you can say network, then device must have a gateway information. Which one information, dear? A gateway. Gateway means last exit interface, or you can say a port. So whenever PC1 sending data, switch receive and switch forward on router. Router this interface receive and router forward by this interface to server. So for PC1, which one is last point to exit data? 0 by 0 or 0 by 1? Router which
0 by
interface?
1.
No, last. For PC1, this one is last. And router will process after lookup, after done decision. Then data will forward by this one person. So router say, for this LAN users, exit point is this one, last exit point. For server, which one is last exit point? This one.
This one.
Now, same design. Now network engineer will define this interface act as a which one person? A gateway for this group. From this group, first IP or last IP, you can assign as a gateway. It's identical. Never define a middle IP. So I'm assigned 1.254 because 1.1 is already used. And MAC address is D. For this interface, act as a which one person? Gateway for this group. And IP is which one? 2.254 and MAC address is E. Now, next task is Loyal Neil Gopi. Have you any idea about how many gateway you can define in your laptop PC? How many gateway IP we can define? How many
One.
IP? Only one. So basically now network engineer will define this two PC. A gateway IP is 1.254. But we are getting any option to define gateway MAC in your laptop? No. So this PC1 send ARP request for which one? For this gateway IP to get gateway MAC. So basically this server also say my gateway IP is 2.254 and I will resolve via ARP a gateway MAC. Done. This server also send whenever define gateway, then send ARP request to receive ARP reply from my routers. So in this case, router will say router maintain a which one table first?
ARP table.
ARP table. In router case, ARP table is different. In layer 3 devices, PC, laptop, server, we are getting a different ARP table. Router case, ARP table storing IP, MAC, interface number, time, this 4 information. And devices, PC, server, laptop, ARP table will define IP, MAC, and time.
Fine.
Interface is not defined. So server also maintain ARP table, IP, MAC, time.
Fine.
Now, this ARP table, two rules available. First rule, by default, a router install on interface, all on interfaces, IP information in ARP table. Automatic. Clear? Second, for on interface, ARP table entry time is infinite. Which one, dear? Infinite. Infinite means never flush, minus. So can you please verify router how many interfaces is on interfaces? Router on interfaces. You can say logical or physical. How many available? 0 by 0, 0 by 1. So 1.254 MAC address is D connected with 0 by 0, time is minus. Never flush. 2.254 EMAC 0 by 1 infinite. This infinite will be flush, but if interface goes down. And whenever this user send ARP request, whenever this server send ARP request for gateway MAC, so this router also maintain 1.1 AMAC learn by 0 by 0 timing start. 1.2 BMAC 0 by 0 timing start. 2.10 CMAC 0 by 1 learn and timing is start. So ARP table process is clear. This users also getting my gateway is 1.254 MAC is D and time is running. This one say 2.254 MAC is E and timing is running. So ARP table is clear. Now next table. Next table is as it is seen, but we are getting a different. In ARP table, which information is stored? Neil, Loyal, Gopi. In ARP table, which type of information installed by router? A group information or IP information? Can you please verify?
IP information.
Only IP, MAC or interface or time.
Yeah.
Now, next table. Router say, brother, I'm storing one more table. And this table name is?
Knowledge table.
And routing table first information we are installing a root code. Root code means how to learn information. And then we are getting network information, sometimes IP. Then we are getting subnet mask, or you can say prefix. Then we are getting interface number always. And this fifth number parameter depends on your protocols, not every time. Some condition we are getting a time. So in routing table, we are also getting some rules. Which one rule available? First rule, by default, router install on by default router install directly connected network information in routing table. Second, if network engineer want to install indirect network information inside routing table, then must be use routing protocols. Any doubt for dear this theory? Done. So can you please verify how many networks directly connected with this router?
2, 0, 1, 0, 2, 0, 1, 0, 0, 0, 1.
Okay, so router say first network connected with this interface, this one. Root code for directly connected network, C, 192.168.1.0 and slash value 24, connected with 0 by 0. From this network, one more interface available, this one, and this interface having a same network IP. So on interface, IP information also stored into routing table. 192.168 1.254 and slash value 32, because this one is single address and 0 by 0. One more network, 192.168.2.0 slash 24 0 by 1. And from this network, one more interface available as a IP, this one. 192.168.2.254/32 connected with a 0/1. So now verify a routing table is built successfully. Loyal Neil Gopi.
Yes.
Now
but,
how
but,
to do?
but the question here, the CL and the C from where it came.
C means a directly connected network or group info. L means from this group interface having a IP, local IP router, same group. So local IP information router store on interface local IP from same group. If having, so store with L symbol. L means local interface IP. L means local interface IP.
Okay, so it takes the interface and the gateway.
What is it? Hello?
It's the the interface and the gateway.
Yeah, interface as a gateway. So store also.
Okay.
Now, one more thing, same design we are using, but now how many tables already installed by device? How many tables?
4.
Two tables. Router will maintain two tables. First table is routing. So copy routing table.
Oh, okay. The tables. Okay.
Router maintain routing table. This one is my routing table. I will do a decrease.
I'm routing. Okay.
Routing table is successfully available, and router also maintain ARP. Copy this ARP table. Done. Now devices also maintain. PC server also maintain ARP table. Copy. This one also available on both PC. Server also maintain which one table?
The other one.
ARP table for gateway.
Yeah.
Because if you want to communicate in different group or other networks, so gateways must be available. Yeah. Now information is completely available on my this project. So how packet flow will done by router? Because switch done data flow. Router how do a data flow? So whenever PC1 say I want to communicate with server. So PC1 generate a data. Inside data, PC1 add layer 2, source MAC, destination MAC. Then add layer 3, source IP, destination. So PC1 says source MAC is A, source IP 1.1, destination is 2.10. Both are different group or same group communication?
Different.
If you communicate in different group, so PC1 automatically put a destination MAC is gateway MAC. Done. And this data PC1 deliver on switch. Switch receive and switch read a layer 2. In layer 2 switch look up a DMAC, and this DMAC switch learn by 0/0. So router receive and router will do first lookup in which table, dear?
Okay.
Routing table. And router verify always. Switch lookup on layer 2 which one MAC address? Destination MAC. Router whenever receive the data, router lookup into layer 3 which one IP? By default, destination IP. And destination IP lookup into first routing table. And routing table, router verify any network available for 2. Any network available? Yes. This network 192.168.2.0 connected with which interface? 0/1. Okay. Router verify, and router also verify from this network one interface available with local IP having a 2.254 on which interface? 0/1. So router lookup in routing table two information, network and how to reach this network. Then second lookup into ARP table. In ARP table, router verify this IP available on which interface? This one. And what is the MAC of this IP? E. IP is 2.254. Router say I'm sending your data via 0/1 to a server side, but you need to use this source MAC E, because now router will perform which one task here? Proxy. Proxy performed by which layer? Layer 2, not a layer 3 by default. So router say I am sending your data. How to send? Router say I am sending your data, and inside your data, layer 2 source MAC, destination MAC. On layer 3, source IP, destination IP. Source IP is as it is. No worry. Destination is as it is. Now source MAC is router exit interface E, and destination IP is 2.10. Any entry available? Yes. And MAC address is C. So router will put destination MAC is C. Whenever switch receives, switch read layer 2, on layer 2 destination MAC. Switch verify destination MAC is C, forward by server side. Server receive and verify my MAC address is available and my IP is available. But sending by on layer 2 E. E means it's my gateway na? Yes or no? Accepted. After accepted, now route this server say I am sending a reply. How to send reply? Server generate data. In data, server add layer 2 source MAC, destination MAC. Layer 3 source IP, destination IP. Now server says source MAC is C, source IP 2.10, destination is 1.1. Now both are same group member or different on layer 3, source IP 2.10 or destination is 1.1. Can you please verify? Both are same or different?
No, they are different.
2.10 or 1.1 means both are same group or different group?
Different.
Different. If you communicate in different, so destination MAC on layer 2, which one? Gateway MAC, na? Which one is gateway for this server? Which one MAC? E. And this data forward by server to switch. Switch read on layer 2, destination MAC is E. Switch forward on router. Router again look up into first routing table. And destination is 1.1. So router verify 1 dot related network is this one and connected by 0 by 0. How to reach this interface L available with IP 1.254 on 0 by 0. So router lookup is done. And now second lookup into ARP table. What is the IP of exit interface? 1.254. MAC address is D. So whenever router forward by this 0 by 0, a data, which one side dear? This user side. So router say, I'm doing again proxy on layer 2. I'm sending your data on data layer 2 source MAC, destination MAC. On layer 3 source IP, destination IP. Whenever router forward data via this interface, source MAC is 1.254. D. Source IP is 2.10. Destination is 1.1. So destination MAC address entry available 1.1. Yes. Which one is MAC? Loyal Neil A. So destination is A. Whenever switch receive this data, switch look layer 2, destination MAC is A. Switch verify A connected with this side. Whenever PC receive data, PC verify destination IP is 1.1. Yeah, it's me. Destination MAC is A. It's a me. Sending by a D. Last time, which one is my destination, dear? D na on layer 2. On layer 2, destination is D. And now layer 2, source is which one? Same or different? Verify.
Yeah, same.
Same. So accepted. So this one is proxy. Router, modem, access points always do proxy to hide your hardware information. Hardware information means MAC address. Clear? Any doubt for this theory?
No, okay.
Okay. So we do a small lab and then basic internetworking device topic is complete. And now we start IP addressing or subnetting part. Wait, we do small lab and then session is complete. So basically this one is your packet tracer. We discuss complete about packet tracer, one session, complete. But right now you need to learn only data flow. Now connect a router. This one is my router and router connected with two switches. 1, 2, and this side we are getting 1, 2. This side we are getting a server. This one is design we discussed na last time. This one, this one, this side, this side, this side. Now I am saying this one is separate part of group, and this group network is 192.168.1.0/24, and one more design we need to create. This side we are getting a separate group, and this group having a which one network, dear? 192.168.2.0/24. No need to discuss configuration because this theory configuration we discuss again in next topic. Hello, Neil, Loyal, can you hear me now?
Yes.
Okay.
Yeah.
Okay. Now, so group is ready. User IP is 1.1. This user IP is 1.2. And this server having IP is 2.10.
2.10.
Yeah. So basically, first we need to go to router. How to configure router we discuss later. But right now I'm doing a configuration little bit fast because this configuration no need to discuss right now. We discuss separate lecture. 1.254 as a gateway. No shutdown. Because router every interface in down state. So manually say no shutdown and IP address 2.254 subnet mask. Show IP interface brief. Done. Now. So go to users and assign IP 192.168.1.254. Sorry, 192.168.1.1 and gateway is 1.254. This one PC also IP and gateway 192.168.1.2. Gateway is 192.168.1.254.
The gateway in this case is your switch, right?
No, gateway is router interface. Na switch as a layer 2.
Router.
So you don't have any IP. So 2.10 gateway is 2.254. Now, so if you go to PC1 and try to communicate 1.2, communication is done. But right now, if I'm saying if you don't have gateway, for example, then communication also done because both are sitting into same network. But if you are saying I want to communicate with 2.10, so read the error. We are not getting a reply. We are getting some message. Wait. Which one message we are getting here? Read the message.
And timed out.
Which one message?
Request timed out.
Request timeout.
Request timeout. Why we are getting a request timeout? Because this user don't have any gateway MAC. So gateway IP. So gateway IP is 1.254. And if you're trying to communicate now, go to router and verify first thing. Router having ARP table, show IP ARP. In ARP table only 2%. Now this user say I want to ping my gateway first. 1.254. Done. If you ping, then automatically ARP request forward and this router maintain one more ARP entry for 1.1 and time is running. Clear? Now,
Okay.
this user if say my gateway is 1.254 and I want to communicate with gateway first. So router again maintain ARP entry for this user.
Yes.
Verify. One more entry available 1.2. Done. Now, if server say I want to communicate with my gateway first. So gateway is 2.254 and now ping 2.254. Done. So router again maintain one more ARP
Check
entry
the
for
ARP table. Yeah, it's there.
2.10.
Yeah,
Done.
it's there.
Now router also maintain one more table, show IP route. So routing table C means network 1.0, 2.0 and same network IP also available with L 1.254, 2.254. So whenever this user say I want to communicate with this server, so router will perform proxy. Can you please verify this PC having a MAC address is, verify which one MAC, copy this MAC PC. This PC MAC is this one. 9EE. A router, this interface MAC is, we need to check. Hold on. Show IP ARP. And ARP table 1.254 MAC address is this one. Copy and go to this side. Hold on. Close this one. Paste this side. This one is router interface MAC. This one interface. And router 0x1 2.254. This one is MAC. Copy. So router say this interface MAC is this one. And this server also having some MAC. So we need to copy from ARP table. 2.10 MAC address is this one. Copy. No need to go to PC na server.
Yeah.
Done. Now go to symbolization. Start. And now go to this PC and say I want to communicate with ping 2.10. And now verify. This packet will generate and verify. Source MAC on layer 2. 9EE is source MAC, that means PC. And destination MAC is which one, dear?
The interface for yes,
Gateway
this one.
MAC. Gateway MAC. Source IP 1.1, destination is 2.10. Now this data forward on switch. Switch look up into MAC and MAC find on router. Router receive and check routing table. And now router forwarding on server side. That means outgoing time, router will put a source MAC is which one, dear? Which interface MAC? 00 or 0x1? Which interface? Which interface MAC, brother? Verified. Source MAC is DD02. Now this DD02 PC MAC or router MAC? Router which interface? 0x0 or 0x1? PC MAC is this one, 0x0 this one, and 0x1 this one. 0x1 MAC, na? So exit interface MAC. And destination MAC is? Destination MAC is which one? 1.4 AC. That means server. Source is again 1.1. Destination is 2.10. So router perform which one task? Proxy. Which one task, dear? Proxy. Because in my data, whenever this user send data, so incoming time, in time, whenever packet incoming on router, so source MAC is PC MAC and destination is gateway. But whenever router forward this packet another network, so source MAC is router interface and destination is device. 2.10 MAC address. So that is the reason we are calling router perform every time, dear. Which one task? Proxy. Server will receive this packet and whenever server forwarding reply, outs time. So verify source MAC is 14 AC, that means server, and destination is which one? Server gateway DD02. Now, whenever this data switch receives, switch forward on router. Router again look up first routing table and then ARP table. Router find out this destination IP 1.1 available on 0 by 0. So destination is 1.1 available on 0 by 0. That means source MAC is 0 by 0. Interface DD 0 by 1. And destination is 1.1 MAC. Which one? 9AAA. So router will perform which one task every time? Proxy. And this user will accept. So basically, router, all interfaces, physical or logical. Go to router and verify show IP interface gig 0 by 0. Which one feature is enabled here? Which feature is enabled?
Proxy RP.
I will show you some short theory about proxy R. Any theory available? No, you can say proxy ARP means hide layer 2 information, you can say. And whenever router forward data from one network to another network to change source MAC. Which one MAC address here? Source MAC. Okay. So go through this video. We meet again tomorrow and we start now IP address and subnetting part. Which one part? Neil, Loyal, Gopi?